In one of the previous topics, we discussed about the mineral admixtures. Here we are going to discuss about chemical admixtures. Chemical admixtures are water-soluble compounds. Based on the function, we can divide them into three categories. Air-entrained agents, set controlling admixtures. We have retardants and also accelerant under this category. We have plasticizing admixtures. We have plasticizers and superplasticizers under this category. They are water-reducing admixtures. There are also miscellaneous admixtures that do not come under the above category, such as shrinkage reducing admixtures, corrosion inhibitors, expansion admixtures, polymer latex, so on. Let's discuss more details about the main three chemical admixtures. We'll start with air-entraining admixtures. Air-entraining admixtures facilitate the development of a system of microscopic air bubbles within the concrete during mixing. In a concrete mix, we can have accidental air and entrained air. Air can trapped in the concrete mix during mixing, and this air we call the accidental air. We can get rid of accidental air by vibrating during concrete pouring. But in some situations, we need to purposely create air bubbles in a concrete mix. This air we call entrained air. It is evenly distributed throughout the concrete. We need to add air entraining agents when we do concreting in freezing environment. Water trapped in concrete will become ice in freezing environment, so it expands volume. We need to provide space to this expansion, otherwise concrete will crack. Also, when we do concreting in sulfate affected area, we need to add air entraining agents to concrete mix because the concrete volume will expand due to the reaction with the sulfate. Again, we need to provide the space for this expansion, otherwise the concrete will crack. However, as a general rule, 1% increase in the concrete air content will decrease the 28 days compressive strength by 3 to 5%. Now let's see how these air-entraining admixtures work. Air-entraining admixtures do not generate bubbles. They simply stabilize microscopic bubbles that are created during the mixing process. It reduces the surface tension of mixing water to promote the development of microscopic bubbles, and also it stabilizes the bubbles by forming a sturdy shell that repels water, hinders the coherence, and promotes attraction to the cement and aggregate particles. Now let's see how the concrete durability is increasing with the air-entrained admixtures. Air-entrained admixtures increase the resistance to damage from a cyclic freezing thorough cycle, and it increases the resistance to scaling from de-icing salts, and also it improves the workability and it reduces the segregation and bleeding. The second type of chemical admixtures are set controlling admixtures. Set controlling admixtures are used to modify the time of setting. There are two types: retarding admixtures and accelerating admixtures. Retarding admixtures extend the time of setting. Concrete that has an extended set time is needed when we have to do concreting in a high temperature environment, or else when we have to transport concrete over a long distance. Accelerating admixtures reduces the time of setting and accelerate early strength development. They are used in cold weather to compensate for the effect of low temperature, and also we can use it for repairing a busy highway and also constructing high-rise buildings. The third type of chemical admixtures are plasticizing admixtures. We use the plasticizing admixtures to improve the workability of a concrete mix without increasing the water content. By adding plasticizing admixtures, we can achieve a higher strength by decreasing the water to cement ratio at the same workability as that of an admixture-free mix. And also we can achieve the same workability by decreasing the cement and to reduce the heat of hydration in a mass concrete. And also we can increase the workability to provide easy in placing concrete in inaccessible locations by adding plasticizing admixtures.